Which brings us to some of the topic for tonight's talk. Now, almost about 10 years ago, Hal Varian made the now famous statement, "The sexy profession of the next decade will be statisticians." This was in 2008. Now, a decade has passed since, and I think his words certainly ring true. It's so sexy that it has spawned many names. Things like big data, data science. This was all the result of a phenomenon that Hal Varian saw unfolding. Clearly, the need for statisticians clearly exceeded the capacity of the statistics profession. And this is familiar territory to many of us who work in statistics. So many people in so many areas need to do statistical analyses, need to do some statistical thinking. And the need for proper statistical thinking is ever more important than ever. And that's what Hal Varian saw. So I'm really excited about the emergence of the data science as a unifying movement, not just for people who do statistical analyses, but all of the other work around data and data processing that is required to make this happen in today's world. So the data science is an opportunity for all of us in different disciplines to combine our knowledge together to solve problems. And I particularly like the emphasis on teamwork within the data science movement. This is a continuing theme in many conversations, in many talks. So tonight's speaker is Antony Ugoni from Seek. So I think Antony will be someone Maurice Belz will be very proud of, someone who's been trained in statistics and has gone off to really make a mark in industry. So Antony began his career as a biostatistician, and including co-authoring more than 50 peer-reviewed papers in medical research. And from the year 2000, he had a change of career. He moved to the National Australia Bank, where he worked on many groundbreaking projects, including in the credit card fraud analytics group, which was one of the first of its kind in Australia. And he eventually led the customer analytics team. And during his tenure there, he identified more than $100 billion worth of revenue opportunities. From 2013, he moved to Seek to develop the data science team there, which now is more than 100 people. It's clear that Antony Ugoni is very much one of the Australian leaders in data science. And I also note that he served on the branch council of the Statistical Society back in the 90s. So he's very much supported our profession all the way throughout his career. Would you welcome to the stage Antony Ugoni?
How data science has allowed me to come up on stage so many times after the word sexy has appeared on the screen. I've got to tell you, when I was growing up and wanted to be a mathematician at high school, the combination of those two things were the furthest thing from my mind. So I need to identify you lot here in one of three groups, because I'll need help. I'll need help from at least one of you to help me escape at the end of tonight. So I'm going to define the three groups. So wait until I've got to the end of the third definition, and then we'll come back, and I need you to put your hand up and tell me which group you're in. So the first group, if you identify as a bootstrapping, hypothesis testing, getting mean and regressing, and fully confident in your interval statistician, that will be group one, yeah? These groups are mutually exclusive, so you can't put your hand up in 2 or 3 groups. Group 2, you're a computer scientist. Programmer, data engineer, developer. And group 3 is not group 1 or group 2. So if you're in group 1, can you let me know who you are? Put your hand up, please. Hand up high. This is the Belz lecture. Be proud of who you are. There are some people I'm looking at who should have their hands up and don't. Okay. Group 2, that Dow tribe of computer scientists, okay. And the cool people, group 3. Awesome. All right, group 3. You could be in for a treat tonight. Just by dearth of the title that I've put up there, the computer scientists don't like me already. And I'm going to give them a bit of a kicking as we go through this presentation, all in good fun, just to make a point. In group one, my people, the statisticians, they've turned up tonight looking at that title, thinking, finally, this is our time. And the big 100 kilogram bloke at the front is going to defend our reputation. And I'm going to give them a bit of a kicking as well. So for group three, at some stage, group one and group two might come down here and grab an ankle each and head off in different directions, and I need you to jump in and help me out. So, I'm a bit nervous tonight, and I'll tell you why. Because the clicker doesn't work. Try again. The clicker works. All right. I'm going to tell you a story. The origin of Once Upon a Time, we can't actually pin it onto one person. We think it's one of these three. I come from Italian heritage. I can have a really good crack at 2 and 3. My French is hopeless, so I'm not going to have a go at either of them. But once upon a time, there was an 18-year-old white male brought up in the western suburbs, standing in his overalls, working at a factory at the end of high school, waiting for his mum to come down the road with the letter that said, "This is the university you go to next year." This particular individual is best defined as a bit of a blunt instrument. He had plan A, which was to come to the University of Melbourne and study physics, and he had no plan B. So what do you think happened? Plan B, which there was no plan, actually occurred. His marks were nowhere as good as he thought he was. Completely forgot, because there was only plan A, what his second and third preferences were, and ended up not doing physics, not at Melbourne University. He stood in line at the Union Hall in February, because back in the days, what you would do is you would go to the Union Hall, you would buy the curriculum book, you'd look at subjects with your eyes on paper, and then you'd stand in line for 3 hours while you were enrolled. Look it up, kids, it really happened. And so he filled it out: physics, electronics, maths, discrete maths, and there was this block, there was this half a unit of space in his curriculum that he needed to fill out. And so as he stood in that line, he scoured through the booklet, and there was this thing called statistics, and it fitted right into his timetable. And the prerequisites were you needed to be kind of average at maths at high school, which, as it turns out, I was. And so I turned up on day one. And I don't know if most of you remember first year statistics. I don't know if most of you remember first year undergraduate, but on the totem pole of kind of where you fit in the university system, it doesn't get any lower than first year undergrad. Yeah? And so as you attend, particularly these big lectures, people don't really know you. The academic staff don't really know you. And the academic staff turn up and they teach this subject because they have to. Yeah? Apart from one guy who taught first year stats, and he didn't teach it with a twinkle in his eye, he taught it with lightning in his eyes. He was so passionate, and he's sitting right at the front today, that's how passionate he is. Bob Stoddy, he was so passionate about what he was teaching and how he was teaching it. I was hooked from that first lecture. First year came and went, I had great marks. Second year came and went, and I started believing my own publicity and failed second year stats. Thankfully, the faculty looked kindly upon me and let me do a supplementary exam, and I managed to get through to third year. And so the third year occurred, and I started getting a real taste for this discipline. And I was never a great student, and I wasn't a great student for 2 reasons. First of all, capability. I'm nowhere near as good at mathematics as I like to think I am. But the second reason is, a semester was never long enough for me. In a semester, what I wanted out of every subject was I wanted to learn that subject. Yeah? The other 29 students in third year stats, they didn't want to learn the subject. They wanted to pass the exam. So they would study to memorise to get through the exam. And I've been an academic. We are not very creative year on the exams that we set. So for undergraduates, here's a tip. Just look at last year's exam. You'll get close. But I wanted to learn, and a semester wasn't long enough for me to learn, about a semester and a half. So halfway through the next semester would have been an awesome time for me to do the exam. But the faculty wasn't listening. And so I was an average student. And as an average student, you're not really on the radar. You're not on the dean's list. But I got good feedback from the lecturers. Anthony, you ask really good questions. But I was a B student. And so I did honours, and so I did masters. And over the course of that time, when I finished masters, I was busting out of my skin. Busting out of my skin to start my career. Now, has anybody here had children go through kind of junior high school? And I'm of an age, now that as I look up into the crowd, there are a whole bunch of people in here who can still remember junior high school. Anyone? Does anybody know what that is up there? This is going to be a long night if you guys don't participate. Yes, there's a hand. Footy cards. Yep. This is what kids do to identify and keep abreast of their heroes. Yeah, they're football heroes. That is truly my footy card book, yeah? From 1992. I get this every quarter, and my wife says, you've got mail, you don't read it, but I sneakily read it because I'm keeping up with all my heroes, yeah? The people who work in this industry, I think, are quite amazing. And so to be here tonight is quite extraordinary for me. So a couple of months ago, I was in this is being videoed and recorded for prosperity, right? Yes. All right, so I need to be careful with my words. So a couple of months ago, I was in a situation where you may or may not be allowed to look at your email as it appears. And this thing popped up on my phone. Brief description. Dear Anthony, Belz lecture. Dear Anthony, I would like to invite. It's Belz lecture time. I'm going to that. I go to that almost every year. Here's the CRM system putting out an invitation to who knows how many hundreds of people, inviting them to the Belz lecture. Oh God. Dear Anthony, I would like to invite you to give the Belz lecture this year. And just to calm me down, Damien put it right out there. This is the premier annual event, yeah? So in the back of my mind, the email pops onto my phone. I think, it's the Belz lecture. I'm going to get to see one of my heroes kind of perform, see who gets picked, and then this pops up. Now, in my day job, I get to do a lot of public speaking, yeah? At Seek, we're really proud of the fact that we're using our data to help candidates find careers that they may not have found otherwise and help hirers be more efficient. So I do presentations, or I do more presentations than I actually do data science. And there are some of my staff in the room here today, they'll say, you do no data science, Anthony, you just approve annual leave. I do a ton of presentations. I'm also involved with the business school and I do some lectures through there. I love being on stage. I'm an introvert by nature. I love being on stage. It's the small talk at the end of the presentation that really troubles me. I can't begin to tell you how nervous I am to be the Belz lecturer here tonight. So, now I've said yes, and then I remember, okay, that original email, Damien sent me some more details, so I better look at those details. Clicking. You can see the titles of the previous lectures here. All right, better have a look. Now, as Damien said, the Belz lecture has been going for 50 years. Here's a sample of Belz lecturers, people who get to call themselves a Belz lecturer. Here are 4 people who taught me. I'm almost certain I know one's in the room this evening. So here I am standing up at the premier event of the Vic branch, and here are a whole bunch of people who've given this before. They know if they want to do a bit of digging into their deep records, what I don't know. Yeah? They actually marked me down for stuff that I don't know. That guy, 2006, Rob Heinemann, I don't think Rob's here tonight. There's a phone booth on the corner of Swanson and Eldrin Street. Sorry, there was a phone booth. I'm going to say this a lot tonight. Look it up, kids. And I jumped in that phone booth one day, and the conversation with my girlfriend at the time went like this. I got the mark. Oh, sorry, take a step back. Back in the days, you didn't look up your mark. You came onto campus at about a day after the lecturer promised that they'd post the results very publicly on a notice board in the faculty, so your shame was there for all to see. And Rob Hyman taught forecasting in the old, I don't know if it still exists, the Key Centre for Statistical Science. Is it still going? Yes? No? I'm distant memory. So Rob taught me that subject. My girlfriend on the phone, hey, I got the results. Her question was, how did you go? I said, oh, I got a high distinction. She said, I thought you said you failed. There is no doubt in my mind that I failed. And 20 years later, I still have dreams about that guy pulling out my old paper and remarking it and taking my master's degree away from me. The 3 other guys have seen through me too. Kerry Mengerson, she's been a Belz lecturer. You need to look up her profile. It's quite extraordinary. Damien said that I used to be on the Vic Council in the 90s. We ran a one-day workshop in the 90s, and she was one of 4 speakers on the day. I picked up Kerry from the airport and took her out for dinner the night before, and it immediately became apparent to me, A, my lack of capability in the discipline. She's an unbelievably smart mathematician, but also my complete lack of ambition. Compared to what she was trying to do and get up and running, you have to look at her profile, is extraordinary. So she's a Belz lecturer. This guy published the book with this guy, this book, Robust Estimation and Testing. This is a fantastic book. Now, I have 2 kind of passions that I like to spectate outside of work, AFL football and golf. And I've met footballers, they're just guys. I've stood at the first tee inside the ropes on corporate days with some of the most amazing golfers around the world and had a chat with them. Let me show you the autograph that I got from Simon Sheether. It's on this page here. I was a bumbling mess. Couldn't talk to him, couldn't get the book out, couldn't ask. Because I think these people are amazing heroes. In my eyes, the esteem to which I hold these people and the rest of this society is at the highest levels. So, bumbling mess there. I saw John walk in. Where's John? Put your hand up, John. There he is, back there. So John Carlin, another amazing statistician, not just in Victoria but in Australia. John marked my master's thesis. My master's thesis came back with so much red ink, I was sure that there was a homicide victim lying in his lounge room floor. And yet, so he's up there. All well, it was on the money too, John, all deserved. I don't hold grudges. I do hold grudges, but not for that. Everybody in here hopefully has heard of Niels Becker. Niels was Dumbledore before there was even the thought of Dumbledore. Yeah? He floated through La Trobe University, a tall, thin guy, amazing presence, an amazing intellect. And I can remember 3rd year, the first lecture of 3rd year, he walked into the room, grabbed, with no props, no book, no notes, grabbed a piece of chalk, look it up, kids, went to the blackboard and then proceeded to show us how to do maximum likelihood estimation. Now, for the academic statisticians in here, and even for me, at my level of kind of capability and stats, I can do that. But at the time, that was for third years who had never seen that technique before. That was kind of mind-blowing. And then I proceeded to masters, and I wasn't kind of doing my work. I was churning through supervisors, and my second supervisor left because I'd been taking so long, and Neil sat me down in his office and said, "Anthony, I'm leaving La Trobe in 6 months. I will be your last supervisor." You've never seen a thesis written as quickly as the effort I put in after he put the fear of Becker into me. And then there is this bloke. I saw him. Where are you, Chris? Chris taught me as an undergrad. Sorry, he wasn't the undergrad. I was the undergrad. Yeah. He taught me undergrad, honours, masters, and was the first was my honours supervisor, and was the first master's supervisor I churned through. And from day one and to today, I think Chris doesn't know my name. And the reason why I think he doesn't know my name is because he calls me mate. Yeah? For somebody of kind of his stature and intellect and his career, to be referred to as a mate kind of rocks me back on my heels every time. And I'm about to go up on this list. And so I thought, right, where do I sit? So this is a lecture held by the Stat Society. So I did some analysis, and I did analysis on these people, and because I couldn't get all the stats on all the people, there's some sampling. So I estimate that just this group of people here have put out 15 books. And of course, there has to be a confidence interval, right? So somewhere between 10 and 21 books. Between peer-reviewed articles, letters, abstracts, etc., this mob have put out 3,000 publications. They've been cited more than 150,000 times. They've got quite an impressive H index. That's a measure of kind of influence. And just for good measure, this group have played 10 AFL games. No kidding. For those of you who don't know, Niels Becker played 10 games in the seniors for the Western Bulldogs. I have no idea why he chose a career in mathematics when he could have been a sportsman in the Australian landscape, but whatever. Now, if I'm the null hypothesis, let me tell you, this group is statistically significantly better than me. So, apologise if I appear a bit nervous tonight. Now, my dad was a great mentor to me. And as I aspired to do things, one of the things that he coached me on was, have aspirations, but when you start out, know your place. So does anybody know who these greats are? Can anybody pick out one of them? No? Let me make it maybe a little bit easy for you. I'll put up some of the more modern greats. Recognise those people? These are all Olympians. Yeah? For those of you who have been Australians for a long time, Shirley Strickland, Murray Rose, Betty Cuthbert should still be household names to you. These are famous sports people. Edwin Flack was our first Olympic medalist. Bobby Pearce actually had an amazing rowing career. Everybody's heard of the torpedo. Lydia Lucilla should have been our first gold medalist at the Winter Olympics. Betty Cuthbert was an amazing athlete. And then we've got this bloke here, Stephen Bradbury. What people don't realise is Stephen Bradbury has 2 Olympic medals. One bronze that he took out in a relay about 10 or 12 years, not 10, multiples of 4, about 12 years before he pulled out his gold. Stephen Bradbury won an Olympic gold medal, not on the back of 4 people falling over in front of him. That helped. But Stephen Bradbury put in a lifetime worth of effort, hard grind, getting up early every day, just wanting to be the best that he could in his industry. He almost died, lost 4 litres of blood in 60 seconds. We only hold about 6 litres of blood. had his neck broken on the way to that gold medal. Now, I've never almost died for the sake of stats. I don't know if I'm prepared to. But in terms of Belz lecturers, I consider myself to be the Stephen Bradbury of the Belz lecture. So, here's the bit that the statisticians turned up for, the crown jewel. Finally, somebody's sticking up for us and putting us in the rightful position. This clicker isn't giving me much happiness. There we go. So let's just remind people, what is data science? There are many definitions. I like this one, it's nice and simple. It's the intersection between computer science, and just because I'm trying to be antagonistic tonight, I'm going to call it hacking skills, maths and stats knowledge, and what we call substantive expertise. And all that means is you know what you're working on and why you're working on it. In business, we just call it full context and the ability to know that you're doing something that's actually going to create value for the organisation. I'm going to, for the rest of the presentation, I'm going to ignore substantive expertise. I'm just going to assume that people know why they're working on stuff, but that's actually in data science, in corporate, not just Australia, but around the world, it's not a given. Yeah? But for the moment, I want you to look at the intersection that would exist if we took the maths and stats knowledge out. What happens if you've got computer science skills intersecting with some context of business? Danger zone? Yeah? So this is independent research that calls out that if you put a computer scientist in the business, you could break stuff. Only by putting the maths and stats stuff in there do you get data science. So let's travel backwards in time. Is stats the crown jewel? It's just a couple of moments in time for both the computer science and the stats industry to make my first point. So in about 2006, roughly, AWS gave us cloud computing on demand. Now this is amazing capability. We have an algorithm at Seek, which we run every night. Every day we get about 10,000 new ads, free text. And what we do is we take those 10,000 ads and we compare them to about two years of history. And that's about 5 million ads. We take 10,000 ads, compare them to 5 million. I'm going to embarrass myself. That's about 50 billion comparisons. We do about 50 billion comparisons every night. The reason why we do that is we send out an email that says, hey Anthony, just want to let you know, we saw you here 10 months ago, you really like this job. I just want to let you know there's another one like it. Now, cloud has given us the ability to do that. Now, if I wanted to do that 10 years ago, when I was at National Australia Bank, that's $1 million to do that. And if I wanted to double the speed, that's another $1 million to do that. I get an invoice every night from AWS, and it fluctuates, so it's hard to plan for, but it kind of jumps around between $6.50 and $7.50 every night to run that algorithm. So props to the computer science capability. The ability to crunch through data and store data is unparalleled. It's amazing capability. Backwards in time, in 1962, kind of had our first go at computer science as a faculty at a university, and in 1959, we think is the birth of machine learning. 1943, I apologise, I've noticed I'm missing some quotation marks, so it's a bit messy. 1943, first recognisable AI, and I'm going to give you the first mechanical calculator, yeah? Just to make this a fair fight. If we go back to 1623, first mechanical calculator. Let's call that computer science. In 1972, most hardcore statisticians know of this book. Most of them will have it. Kind of open up the capability around linear modelling on a whole variety of problems. In 1926, Fisher gave us, started the dialogue around some experimentation, field experimentation, and just prior to that, we had statistical experimentation. 200 years ago, we had two people kind of independently give us least squares. So our first kind of prediction capability so recognisable prediction capability is just over 200 years old. So hold on to yourself here. Not even the log scale helps you guys. 1,200 years ago, we've got texts that talk about probability and statistics. Yeah? And 5,000 years ago, we started talking about maths. And if you think about what we were doing 5,000 years ago, we were talking about statistics. I needed to know how many sheep I had. Now, I don't have the vocabulary to kind of make the comparison and let you know how I think about this, so I'm going to quote a famous philosopher called Homer Simpson. Nya, 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 we were here first. So that's my first point about statistics being the crown jewel. Then there's a whole bunch of other stuff. Now, the statisticians in the room are going to look at these things and they say, what are you talking about, Anthony? Like, this is our bread and butter. But a whole bunch of stuff here gets missed, gets lost in the marketing that is data science, that the computer scientists have taken over, because we have to remember the marketing of computer science has not come from academia. Like the big push behind computer science, sorry, the big marketing push behind data science have come from the software people. Yeah? And they're computer scientists. So here's something that I see computer scientists get wrong all the time. What's Y and what's X? Now, the statisticians in the room are looking at me saying, I can't believe it's 35 degrees out there and I walked in to hear this bloke talk about the outcome variable and the predictor variable. This is really important stuff. When you get this wrong, you put a whole bunch of things into field that actually will erode value. Now, the example that I always give is when I was in medical research and teaching, I would give a data set, a very simple 2-column data set to students. Column A, lung cancer, yes, no. Column B, have you ever smoked, yes or no. Now, without fail, in week 2, gave that out in week 1, in week 2 the students would come back and present their findings. And about 50% of those students would tell me, Anthony, based on this data set, if you ever smoked, you've got a higher probability of getting lung cancer. That's correct. The other half of the students would come back and tell me, hey Anthony, if you've got lung cancer, chances are you smoked. Yeah? That's putting the X where the Y should be. And that's not such a bad message in plain English, but the thing about sampling the data is when you sample your data, you're sampling randomness in Y, and typically, particularly in an experimental situation, you're fixing the X. Yeah? You're not seeing a natural kind of randomness or variance in your X. And so when you swap these things around, things can get really hairy. We know this stuff. We, Group 1, knows this stuff. Weak learners, computer scientists. Have you ever used the phrase weak learner before? Put your hand up. Be courageous. You're not a computer scientist. You'll leave your hand down. I did say some hands. Yeah, no, you raise your eyebrow. Put your hand up again, sir. Have a look, yeah, smiling. Did you put your hand up? Yep, up, not down. There you go. Did you know that weak is a 4-letter word? And when I hear people refer to the beauty of logistic regression as weak, I have a 4-letter word that I want to use too. These so-called weak learners, I will go head to head with a machine learning crack at a data set, and I'll use logistic regression. And if I get myself into the problem and understand what I'm trying to solve and what I have to solve it with, I will bet you any day of the week that my basic weak learner with good feature creation beats your blunt force machine learn model. Yeah? There's a lot of talk about we've got these tools that come in and it just sits over your data and you don't need data scientists. We just got to fold out model after model after model. The weak learners do amazing work as long as you know what you're doing. There is an elegance and a poise, the 2 words that I use in our mathematics. Maintains robustness at the same time. Machine learning models, they can spiral off into the universe at any moment. Clicking away, Maybe my thumb's too thin. Okay. And so what I mean by that is, a statistician says, I'm going to get this data, and here's what I'm going to create for you. Once upon a time, Act 1, Act 2, Act 3, and they lived happily ever after. We know everything that goes into that model. We know why it worked, and we can spit something out and know why it's spitting that out. The computer scientist says, my model works. No idea why. Are there any computer scientists in here who disagree with that? Yeah? Oh, I got really nervous putting your hand up then. All right, because I think what you were going to say, you're going to go down this path, right? Explainability. This has been recorded, so I can't use the words that I want to use about your crack at explainability. Our models are powerful, mathematically elegant, and completely explainable. Yeah? When I first started hearing about explainability, as if you've ever been in a car accident, you'll have this reaction. You have the car accident, you get the rush of adrenaline through your body, you do your legals, you take off again, hopefully your car's still drivable, and about an hour later, you have this moment where you say, did that just happen? Like, I can't believe that just happened. When people started talking to me about explainability, having had 20 years as a statistician, helping publish papers in medical research, where we had to tell the public, these are the groups who are exposed, and here are the high-risk groups and the low-risk groups, and here's how they might interact with other variables. The fact that you're talking about explainability, you're a bit late to the party. We work in a world where we know the difference between probabilities and scores. So in computer science, in machine learning, a large number of algorithms require an artificial split of your ones and zeros. They work really well when 50% of your outcome is a yes and 50% of your outcome is a no. But we know that longitudinal studies win. When you try to explain something, the longitudinal study is the most powerful study. We know why. And we get to model probabilities. We will always start trying to model the pure probability. It's in our nature. And the reason why that's important is because we've got this notion of the expected value. Now again, the statisticians in the room are looking at me saying, what are you talking about expected values? But in a business context, and even in a medical context, the expected value is really important. Yeah? What's the utility? Because these probability models, eventually you need to make a decision. Once you predict something, the probability that I have a car accident on the way home, it's small. Yeah? Oh, there's no wood for me to touch. It's all artificial. It's really small. But the utility of having a bad accident is really high. And when you put those things together, it makes you really think about driving recklessly. But if you're trying to recommend a job to a candidate, what's the worst thing that can happen if I, email of 10 recommendations, send Antony Ugoni a recommendation that he should look at this surf life-saving role? It's no big deal. Yeah? So understanding the utility of the outcome and coupling up with the probability is a really powerful way of making trade-off decisions. And we've been doing that for years. I call this the new dawn of experimentation. I need to go to my notes. This does my head in. We've been doing experimentation for a long time, and we teach our undergraduates a whole bunch of techniques. How many people here are in the digital industry? 1, 2, 3. I've got a whole bunch of my staff here who aren't putting their hands up. 4. Yeah? You know what the sexy phrase has been for a long time in digital? A/B testing. Yeah? We've been calling that two-sample testing for how long? Somebody help me out here. Yeah? 100, Chris? Who knows? Yeah? We also talk about champion challenger. How sexy does that sound? Champion, challenger. That's a two-sample test. We also talk about, there's this new technique that people are talking about. It's called the AA test. That's a crossover trial. Computer scientists, your minds are going to be blown when you come across factorial design and the fully crossed factorial design, and then you realise that a pivot table beats your model. Yeah? We've been doing this stuff for 100 years. We invented the link function. Again, the statisticians are looking at me kind of in disbelief. But do you know how important the link function is? Is there a computer scientist in the room who wants to have a crack at telling me how important the link function is? Is there a computer scientist in the room who knows what a link function is? No? Yes? It's going to be a long night. R models, oh, you're too late, I'm on a roll, mate. R models, statistician models, do the same sort of thing that computer science models do, yeah? Sometimes they want to gallop off into a random direction and you just have to let them because that's what the data's saying happens. I need to go over there because I found pattern over there. The link function keeps the integrity of the thing that you're trying to model, yeah? As simple as that. If you're trying to model a probability, you can let the model go off into infinity or negative infinity, negative infinity, and the link function preserves the thing that you're trying to play with, yeah? Now, we didn't invent the next thing, but we made it the hero that it is today, yeah? ROC curves, again, a really simple concept, came out of engineering. But I hear computer scientists tell me all the time, the AUC under my curve is this. What does that mean? Well, it means it's a good model. Why is it a good model? Tell me what the area under the curve means. Statisticians know that it's highly, highly linked to, equal to, a construct out of the Mann-Whitney test. What's that? I'll let you look that up. We also know that two models that have the same AUC, they can have completely different performance because we know what the distributional goings-on behind the ROC curve means. A lot of computer scientists know this as well, but a terrible AUC, that is something significantly close to zero, is actually an amazing model because we understand what's going on in the background. So how did we ever get to this? How do we arrive at the fact that maths and stats seems to be equal in the conversation around data science? Now, let me take possibly my last drink of water. The problem lies with the mathematical community. I'm about to put a word up here. So I'm not talking about individuals. Mathematicians and statisticians are people like any other. They have as much passion about their work as any other person. You have to have more passion to be a mathematician in the modern age, in the last 20 years, because there was a certain stigma attached with being a mathematician. So you need to be passionate about the work that you do. But I believe what we've lacked is the twinkle in the eye that brought this stuff to life for the students who are in the undergraduate classes. I'm about to call out 5 things that I think are really important. And, oh no, sorry, step back. So, I was actually hoping to be able to go to somewhere on the web where somebody's already given this presentation about stats, because I think stats is awesome. So I did a Google search for statistics is. Let's go to the second thing first, because you're all busting to know. The phrase is, statistics are like a bikini, and the quote is, what they reveal is suggestive, but what they conceal is vital. And I want to tell you how brave I am because I clicked on that link on my work computer. The first suggested search in Google, and if you understand how suggested search works, it's an empirical outcome, mostly. When somebody starts typing this, what's the most common search that it ends up in? Yeah? Statistics is hard. For people who are in group 3, who thinks mathematics is hard? Stu? Who else? Yeah, come on.
On a theoretical basis?
In general. Yeah.
In general, if it's applied, that's fine, but if I'm actually reading a theorem
Good. For those people in the room who think it's hard, somebody call out a mathematical function for me that they kind of struggle with if they had to work with it right now. Any function, sine, log. Guys, you're not qualified to answer this question. All right, so I'm going to go with the sine curve. Is there anybody in group 3 who'd like to describe in plain English how the sine curve works? No? The sine curve is really easy. The sine curve is...
There's also an oscillation way, isn't it?
Yeah. It's better than that. It's just the opposite over the hypotenuse. It's division. What's division? Division is the opposite of multiplication. What's multiplication? It's addition. Yeah? What about powers and logs? Let's just talk about a power to make the point. Power is just multiplication. What's multiplication? It's addition. What about calculus? Calculus is a glorified way of finding an area under the curve. How do we do that? Integration. We put together polygons. Lots of little bits, yeah? Lots of little squarey type bits, yeah? Does anybody know how to get the area in a square, in a polygon? It's really easy stuff, yeah? It's kind of side by height. That's multiplication. What's multiplication? Addition. So the dirty secret that the statisticians and the mathematicians don't want you to know is that all of mathematics is just addition. No, like that wasn't that is the actual fact. There is no mathematician in this room who could come up with the most complex thing that they're working on, and there are some brilliant minds in this room who can't wind it back to addition. So mathematics is only two things, I said. It's addition, and the thing that makes mathematics powerful is the equal sign. As soon as we can understand the problem, figure out what the left-hand side and the right-hand side look like, the mathematics just rolls out, yeah? And what a really good mathematician will do when they're working on a problem, when they get stuck, the first thing they think of is, what's the thing that I'm trying to solve again? What am I trying to do? Because the actual techniques, the mathematical techniques, are just versions of addition. We don't get caught up in the things that we're writing down. We get stuck because we forgot the problem that we're trying to solve. So I get really cranky when I see statistics is hard. Are there any statisticians still with me? So, part of the problem is we don't teach with passion. We don't bring kids along and show them these things are actually quite amazing outcomes. These are quite amazing results. So the first one, you watch the statisticians raise an eyebrow here. ANOVA, yeah? ANOVA is the analysis of variance. Like, we've given this thing so little love, we've actually called it something that is passionless, ANOVA, yeah? Now, I'm going to quickly really go through what ANOVA is. Let's say you've got 4 groups. You identify 4 groups of people and you measure something on them, yeah? Height. Now, don't worry that the fact that those data points are one above the other, that height means nothing. It's the spread that you're interested in. So those are the 4 groups. We've made a whole bunch of measurements on heights. Looks like the yellow group is the tallest group. What we're interested in is, do those 4 groups behave differently on this thing? Yeah? So is there evidence to suggest that this is going on? Or this? Are they all from the same group? And how do we do this? It's really easy. We take the 4 groups and we try to figure out how spread they are. Yeah? Are they tightly clustered or are they wildly spread? We call that the randomness. And then what we do is we try to figure out the average. Our best go at trying to figure out if these groups are equivalent to each other is by comparing the averages. And so we've got this idea of spread. Now, I've really butchered this. This is a great teaching slide. But then we try to determine what's the variability between those averages. Yeah? So between those groups. And we kind of come up with an average between group variance. Yeah? And then all we do is we compare that green line to the average of the coloured lines. Is the variance between the groups, is the explained variance bigger or smaller compared to the randomness. And while ANOVA itself isn't all that exciting, what you need to know, and when I talk to graduates, and when I talk to people who start Melbourne Business School Centre for Business Analytics, conceptually, this is all we do. In most of business statistics, most of predictive problems, this is about 90% of what we do. We're just trying to figure out how much of the variance can we explain and how much of it is pure randomness. And that brings it to life. We don't teach that. That was why it was number 5. So if you can just see that it's probably likely that those groups are different, kind of likely, and it's going to be hard to kind of pull these apart, that's all we're trying to do. Number 4, it gets better. Pure randomness. Am I standing too far away? Does anybody know who this guy is? Sorry? Nah, I'll give you a clue. Here's his surname. Lodovico Buonarroti Simoni. I'm Italian. Anybody know who this is? All right. His friends knew him as Michelangelo. If he was Australian, what would his name be? Mick. This is Mick. And translated, he's got a great quote. Whoops. Every block of stone has a statue inside it, and it's the task of the sculptor to discover it. Now, I'd like to lay credit for the fact that I knew this quote. Actually, my barber gave me this quote every time I go in every 2 weeks, and he trims my beard. Every block of stone has a statue inside it, and it's the task of the sculptor to discover it. We spend all of our time. We teach students how to estimate averages or how to fit a line. That's not exciting. Yeah? If you go and tell somebody to fit a line to that data, they'll fit you a line. But if we say to them, go find me a story, go find me what that data is saying, that flips the dynamic straight around. Yeah? Who's heard the saying, and I'm going to butcher it, but all great discoveries didn't start with, I knew that. It started with, oh, wasn't expecting that. Yeah? If we start on the left-hand side and tell people to do something very specific, humans who are financially incentivized to do that are really good at doing that. We don't spend anywhere near enough time telling our students that, you know, your palette to work with is the randomness. Yeah? We teach them how to fit a straight line. Number 3. Number 3. Okay. The statisticians in the room got to get excited. Central limit theorem. How cool is the central limit theorem? Yeah? Anyone? Yes. Damn straight. Watch this, group 3. If I've got data and it comes from this sort of distribution and I sample it and I calculate the average and I hold on to that average, and then I take another sample of the same size and I calculate the average and I hold the average, and then I take another sample of the same size and I calculate the average and I hold the average, and if I do that an infinite number of times, because that's the sort of stuff we do, the distribution of the mean looks like that. So you think, oh, bell shape, expected that. But if I start with an exponential distribution and I sample data and I calculate the mean and I store it, and then I take another sample of the same size and I calculate the mean and I store it, stop me when you get the drift, right? Because I'll keep going. Yeah? The distribution of the mean is normal. Hold on. If I take a sine wave and turn it into a distribution and I sample data and I calculate the mean and I store it, etc., etc., the distribution of the mean is normal. If I take some weird-ass distribution and I sample data, the distribution of the mean is normal. Now, I'm a dad. And as a dad, if you have a kid growing up in the last 20 years, Chances are you've seen the movie Up. Who's seen the movie Up? Old bloke, balloon, canyon, yeah? Hitchhiker, scout, pain in the butt, yeah? And they come across a talking dog. Remember that? They come across a talking dog. And the kid says, can we keep it? And the grumpy guy says, nah. Can we keep it? No. Can we keep it? No. But it's a talking dog. We forget the magic around the central limit theorem. This is our talking dog. This is amazing. Do people not see that that's amazing? You can sample from anything and you can get a whole bunch of insight about the thing that most people care about, the average, with this result. Nobody's with me. All right, number 2. Better than the central limit theorem, it's the Bootstrap. This is amazing. The Bootstrap says, just give me data. Tell me what you want to know and give me enough computing power and enough time, and I can inference the hell out of it, I can estimate the hell out of it. And the thing that sticks right in my gut is that we teach this in a bit of a passionless way, but it's called the Bootstrap for a reason. The origin of the phrase bootstrap, implying that someone is attempting or has claimed some ludicrously far-fetched or impossible task. We named it after something that's impossible, and we suck the life out of it when we teach it. No wonder these kids are going off and doing things other than stats. The last thing, and there is going to be anarchy in this room, let me tell you when you see what it is. Statisticians, because of poor marketing, not by us, by the rest of society who don't want to engage with us, have been trying to push this thing down for years. The hypothesis test. The hypothesis test is one of the most powerful things that we've brought to scientific thinking. I'm going to bring it to life with an example. We can develop it at Seek. One of the things that we're working on is our search engine. We're using a whole bunch of machine learning techniques to make it better. We think that blending with predictive capability and information retrieval techniques makes for a better search for our candidates. So why do you do things in business? You better be doing it because you're going to make the business better, otherwise you won't be working in business for long at all. So the business has this hypothesis. If we build this new search engine, it's going to be better than the old search engine. There's a problem with this approach. The first thing is it leads to confirmation bias. Yeah? So I do him a disservice, so I'm not going to name him. But my executive director, when we first started building our search platform, we would put it into field and he would literally hit refresh, 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 watching the reports of how this thing was performing, and then we'd see a little blip into the success zone. And you go, look, there it is. This thing is successful. Yeah? By framing the fact that we're going to do better leads to confirmation bias. There are an infinite number of ways to be better. 1%, 100%, 5%. What does better even mean? And there's actually no room for this. There's no room for worse. Yeah? And this is really dangerous because there are any number of examples where you do something with the best intentions, both in business, academia, medical research, whatever endeavour it is, where you've actually made things worse. And unless you set yourself up to be able to detect that as well, you could be eroding value. So how about we do this instead? Equals. The new search is equal to the old search. And statisticians in the room, I have to tell you, this is the journey that I take people on who aren't statisticians. And then they go, I get it. Now I understand what that hypothesis is all about, what hypothesis testing is about. It's the same. Just so you know, group 3 and a bit of group 2, that's how we got to that notation, H0, null, the null hypothesis. Just remember this, the null hypothesis is always nothing happens, yeah? Let's just flip it around, equals 0. Why is that important? Well, Now we've got a hypothesis that's a single value. That's all right. I'll answer it if you want. Whoa. It makes the maths easy. Who's ever done mathematics with 0? It's pretty cool, huh? Drops right out. That hypothesis is now agnostic to better or worse. It leaves you open to discover either. And it manages expectations, yeah? So now I can go to my boss and say, you know what, we're doing this thing. I've got no idea what's going to happen, yeah? If anything happens, I'll let you know. We're hoping it's good. If it's incorrectly not rejected, so think about that. If you don't reject this hypothesis, if you say, you know what, the old search and the new search are the same, but that's incorrect, well, you're just left with the old search. There's not too much damage. Yeah? It's a nice little outcome. So as a leader in a corporate, they send you on so many leadership programs, and the one that really stuck with me was something called adaptive leadership. Adaptive leadership is about lifting the burden of ego. Lift the burden of ego, self-esteem, self-importance, and the folly of needing to have all the answers from every scientist, experimenter, leader, and thought leader. Takes the weight off your shoulders. This is an incredibly powerful technique. And again, we suck the life out of it. So I talk about passion. So I want to leave you with 3 things. Can we get the audio? So I won't put this up yet. I've got some verbatim, but it's probably a little bit more powerful if you hear it. Can you get that picture of me down too, Damien?
Later. I quite like that picture.
Well, you know, I would say is that never do anything that someone isn't really passionate about. And it might not always be you in that job, I would say, right? There were times when I had to borrow somebody else's passion. If you're going to make 20 movies a year, if you trust the people around you, then sometimes you borrow their passion. And at a certain point, like, you'll get caught up in it. But sometimes there's a whole period where that person's passion and your confidence in that person is the driver. Because ideally, you would be passionate yourself about every single thing. But when you get to that demand for volume, you realize that actually, because taste is subjective and because of what you have to accomplish, that sometimes you have to borrow somebody else's passion.
Right.
But if there's nobody who's passionate about it, there's no way it's going to be a hit.
Right.
That was my experience. The things that you do because you think you should, those are always the mistakes. Somebody should just love the shit out of it.
So, how many times have you heard students say, oh my God, we've got a stats lecture to get to. Everybody drop what you're doing. Yeah? Never happens. We need our teachers to be that source of passion. We need them to bring the passion of some of the most magical mathematics that you will ever experience, because we lose you. We lose you through possibly being a little bit drier than we need to be. If we bring that passion in, then you'll take it away. And the problem is, we've peeked behind the curtain. There's a whole bunch of mathematics that goes on behind those 5 things. It's amazing stuff. We know how this stuff works. And if you're like me as a mathematician, I'm interested in the problem. Once I've figured out the solution, I'm on to the next thing. So that's our problem. Yeah? We forget that people are looking at this for the first time, and it's quite amazing. So that is the quote. The second last word I want to leave you with is from Sir Francis Galton. Gave us a whole bunch of stuff in statistics. Some of you will have heard of correlation. I'll read it out. Some people hate the very name of statistics, but I find them full of beauty and interest. Whenever they are not brutalised, but delicately handled by the higher methods and are warily interpreted, their power of dealing with complicated phenomena is extraordinary. They are the only tools by which an opening can be cut through, the formidable thicket of difficulties that bars the path of those who pursue the science of man. If that doesn't light a fire under your ass, I do not know what will. The last word of tonight, Stephen Bradbury-esque. If you're an Australian, you know that every 4 years you become an expert in a whole bunch of sports we have no right knowing about. I watched his race. I was worried that there would be a dispute at the end of that race. And then he became the gold medalist. With a click of this button, I now become a Belz lecturer. Thank you very much.
Thank you very much, Anthony. That was a fantastic lecture. And we have some time for questions. Who would like to ask a question? I'll come around with the microphone so that we can record your response. So just hang on, I'm going to come around with the microphone and so that the question can be recorded.
Hello? Okay. Thank you very much, Anthony, for a really good lecture. So just a bit about myself. I'm actually finished my PhD in biomedical sciences, and I do basic wet laboratory experiments, nothing too computeristic or heavy statistics related. And I'm thinking about going into data science / data analytics because I've had that spark in statistics during my first year, learning statistics all by myself. But then I dropped out of doing a major in mathematics because I felt that the mathematics was too heavy for me to cope. So I'm just wondering, now that I've got that spark back in statistics, how should I fuel that further?
Yep, that's a great question. So I can tell you that my brother cost me 6 minutes. Every time I picked him up on the way to work, he cost me 6 minutes. I can tell you that my strategy on the third hole at Royal Park Golf Course was a superior strategy to the friends that I played with. And why do I know this? I know this because nobody cares about that analysis. I've got to tell you, when I told my brother it cost me 6 minutes every morning, you couldn't see a more disinterested face. But what I wanted to do was I wanted to play. Yeah, there were techniques, and I had no data, and I wanted to play. So play. One of our best recruits at Seek, she had an average resume, very average resume, right in the middle of the pack. In her resume, there was a link to a blog. So I went to a blog, and there was a great analysis in there. And the analysis was, how do I optimize, how do I maximize my viewing pleasure of the fireworks on Christmas Eve, but minimize the time it takes to get to public transport? She researched fireworks, understood how high they fired in the sky. She got a topographical map of Melbourne CBD, overlaid the buildings and their heights. She took public transport data, and then she figured out where you should stand. Now, I don't know if you've ever been to the CBD, watched the fireworks on New Year's Eve. You don't care about public transport. And the point is, nobody cared. But she was so passionate about learning, she went and grabbed some data just to play. So to people who are aspiring to get into this field, do the Coursera stuff, do R, do Python, do it all. But where you really learn is where you play. And those are the people who stand out.
Thank you, Anthony. I love the passion with which you delivered the lecture. My question is very general. You mentioned about how the cost of data crunching is falling rapidly from, say, $1 million 10 years ago to $5 now. What would have to be true for the cost of data crunching not to fall any further?
What would have to, for it to not fall any further? I don't know. Because we are still in a world where we're seeing computing power become more and more commoditised. Yeah? So the answer to your question is I don't know. I don't see it getting more expensive. I don't see it staying at the same level. I actually see it becoming cheaper. Yeah. So the answer to the question is what would need to happen? We hit our limit of capability in terms of compute. But we've got miles to go. Yeah. Climb the stairs, Damien. Don't pick on the people at the front.
Thank you, Anthony. I'm in the group 1 that you identified, and I was wondering what you've told us what data scientists and other people can learn from statisticians. What do we as statisticians, what can we learn from data scientists?
Now, let's be clear. To be a data scientist, you need to be a statistician, yeah? Yeah, so let's be very clear about that. But I think what you're asking is, what can we learn from the other side of the Venn diagram, the hackers? So what we can learn from them, I think the most important thing that we can learn from them is to not limit our imagination. So in another lecture I give, I plot capability versus imagination, and we've been held back for a long, long, long time with the ability to actually store data and crunch the data. If you're on any social media, follow data science, follow AI communicators. I'm disappointed in myself every single day, not because I'm a Reformed Catholic, but because there are so many cool ideas that are coming out over and over and over again about applications of AI to problems. And the bottom line is, there is almost no problem that can't be solved if you've got good data. So I was at a presentation yesterday, at a conference yesterday, Institute of Analytics Professionals. We are commoditising legal advice. We're using NLP methods to read through hundreds of thousands of documents and pulling together a case to be presented in court. Yeah? From an industry, now, this might be controversial, but from an industry that limits supply of humans to do the work, we're now making a world where legal advice will be commoditised. We're now making a world where medical advice is going to be commoditised. Again, another industry that has controlled capability or qualified people, and because they need to keep a high standard as well, absolutely, we're now commoditising medical advice. So it's just our imagination. So what the computer scientists are bringing us is capability. Yeah? We need to learn from that and not limit ourselves, because all the problems that we work on at Seek is, you know, I say this with all respect to the engineers that we work with, but a lot of our problems are solved with optimization of code or another node. And that's what they bring. They brought those nodes to us and the tuning. So go hard.
I've got a question. So one of the key passions of machine learning people, I mean, apart from statistics, if statistics was a passion anyway for the machine learning community, one of the key passions is biomimicry, as in we are using this model, which resembles a biological system. We believe that it should achieve a successful prediction because it's inspired by a biological system. And do you think, I mean, what's your comment on such a justification for using such systems or models?
Oh, that is above my pay grade. So I don't know what the justification is, and I'm not qualified to call out what the justification is. A large part of my job at Seek is I employ amazing data scientists, so I really don't need to dive into the work that they're doing. But a large part of my work at the moment is ethics and bias, and putting together frameworks around just because we can do it, should we? The thing that I encourage people who are doing technical degrees is to remember that you're human too. So 20 years ago, we couldn't do too much damage because there was an enormous amount of friction to get my model into field. And for the most part, it was ASX top 20. And so I was doing cross-sell models and a bit of fraud detection. Couldn't do too much damage in that space. Everything's open now. Sorry, everything's up for grabs. And the ability to get something in field quickly is unprecedented. So we need to make sure that our data scientists have all the tools that they need in place to self-check. Yeah? So that's a big discussion. and not just at Seek, but in the industry in general. So what I would encourage is, I'm encouraging people in technical fields, look to the humanities, look to the arts. These people, these environments give you those softer skills to let you consider there's something other than building a model that may not do good if it was built. Yeah? So I don't know where it's going, but I know we need to self-regulate, and we need to do it quickly, and we need to swing the pendulum hard.
Hey, Anthony. Group 2 have much cooler names for things than Group 1. What's your opinion around language when Group 1's talking to Group 2 is talking to Group 1? Things like precision, recall, specificity, sensitivity, all those sorts of things. What's, with such a big team as well at Seek, what's your thoughts on that?
Yeah, no, so that's really easy. So what we don't do is we don't put the data scientists over here and the engineers over there. Yeah? What we do is we work on a problem. And then once we identify the problem, we figure out what do we need to solve that problem. We put those people together. Yeah? So the data scientists, the engineers, and our strategy brethren, along with some experimentation people, are co-located. And even though they might be talking different languages, they have a common language. Yeah? So there's nothing like putting people together to actually get them to talk to each other. Yeah. Yeah. And it's as simple as that. Damien? There are some questions at the front too.
Yeah, thanks, Anthony.
Yep.
I'd like to know what you think of AutoML or its equivalent on all the other cloud platforms, and given that it's going to be used, how we can improve measuring and truly understanding what the best model is.
So you're talking about, so there are two types of AutoML. One is I've defined the problem, I've built a model manually, and now once I know kind of the track of data that I need and the technique that I've used and I've parameterized it, I'll just rebuild that model regularly. Or you're talking about software.
Let the computer decide which
Let the computers,
Yeah.
Okay.
Try 5 models, which one's better?
Yep, but so I just wanted to be clear. So there's a whole bunch of marketing around, just let me put my AutoML over your data and I'll give you cool stuff. The thing is, the data is never fit for purpose. The data is never, ever fit for purpose. The only reason you have data is to run a system that a salesperson uses or a customer uses or IoT produces, and it's built for a specific purpose. And oftentimes you're trying to solve problems. If that problem was easily solved, or it had been solved before, that data would be easily interpretable. But we're always working on the next hard problem, and that data is not fit for purpose. So if any of you work in a retail environment, in an environment where people talk to customers, go and stand next to them and see the data they actually put into the system versus what you think that data is actually meant to be, number one. Secondly, they're very different things. The second thing is, once you know the problem, you need to figure out what the right outcome is, the Y versus X. The computer scientists do this almost as well as the statisticians, but it's the derived stuff. So in banking, when we were doing cross-sell models at NAB, we wanted to know what's the propensity for a customer to take out a home loan soon. And we had a whole bunch of information. Some of the information was, how much money have you got in a deposit account last month? And how much did you have the month before? And how much did you have the month before that? Now, the software vendors would tell you, just throw that in and we'll get you a great model. But the reality is, it's not the amount that you have in your deposit, it's how much has that grown over time. And the ML is really bad at deriving that gradient. I'm going the wrong way, that gradient, right? So the auto ML will do some stuff, but you won't be able to trust what it does. For all the usual reasons, the ML models are hard to explain, but you actually don't know what data it used. Whereas the computer scientists, the machine learners, the statisticians, they've chosen data that's appropriate for purpose. So I'm yet to see an amazing application where there's a data lake, a whole bunch of data, and software over the top that's just spitting out insight that's actually trustable. Yeah? So you need to have strong diagnostics over the top, and that actually takes away the auto. Yeah? So you need to do all the stuff around understanding what your problem is, making sure your diagnostics are actually measuring that outcome, and making sure that the data going in is fit for purpose. And it goes back to explainability, and that's hard. Yeah?
So we'll only have time for about 2 more questions. So apologies for those who won't be able to get in, but let's go with the ones I've seen.
Thank you very much. I wish I had you, Anthony, in 1973 when I studied economic statistics at Monash University, but
Don't name names.
they didn't teach negative interest rates back then. My question is this. You've obviously had a pretty amazing career, and I haven't known about you before. I'm just first time I'm one of these meetings. What is the most passionate statistical study you personally have
Been involved in? Yep. So I love the stuff that I do at Seek. Our mission is to change people's lives. So that's pretty powerful for me. In my previous career, like the one thing, like when I die, this thing has been amazing for me to be part of. And that was to be part of a study that looked at risk factors for cervical cancer. Now, the people who went on to build, lost my words. Help me, Damien. Cervical cancer, preventing it.
The HPV vaccine.
The vaccine, thank you. Whew. The people who went to build the vaccine, those people, one of those people in one of their early studies quoted that study that I was a 3rd or 4th author on. Like that's my tenuous link to a vaccine that kills women in droves. So that on its own, if I do nothing else, that's been highly satisfying. Yeah. And like I said, I'm an average mathematician. I'm unlikely to do something that is that cures, a big disease. But that on its own is it's enormous satisfaction for me. Yeah.
My question's perhaps in a similar vein to the last one, but I hope your response is a bit different. You mentioned in your presentation that quote about the really interesting things happen when people aren't doing just fitting a line to a data, they're discovering something unexpected. And I was just wondering, throughout your career, what's the most interesting thing that either you or people that you've been working with have discovered by accident that's led to some sort of significant or interesting discovery?
Yep. So I can't give you details. I can't give you the detailed analysis, right? But I'll give you the secret formula. Yeah. So, and let me talk specifically about banking because that's the example. Data scientists are in an amazingly privileged position. They've got access to the data. They know what they can do with the data. If they're smart, they're aligned with the business strategy. They know what the business wants. They know what the business needs. So 3 things. But the 4th thing is they're also a customer. Now, if they understand what the business strategy is and they think like a customer, and as a customer, if you approached me with this information, I would totally engage and help you achieve your strategy. You're in that privileged position of being close to the data, know what to do with it, know what the business strategy is, think like a customer. We had 400 triggers, analytical triggers in marketing at NAB, and out of the top 10, 8 of them came from data scientists thinking like that. Yeah? So don't just do stuff because you think, I've got this data and this algorithm, or I've got this hammer, I'm going to turn everything into a nail. If you can engage with what the wider community that you're working in is trying to do, and think like somebody in that community, you pull off amazing tricks. Yeah. Did that answer your question? Didn't give you the answer you wanted because I sell that as consultancy and I'm actually not allowed to give that away, but that's the trick.